We all ready to begin? So tell me, is this the session right after lunch? It is. Okay, so that being the case, I'm not going to hold it against anyone who falls asleep, okay? So welcome to Touchscreen and Stylus and Mouse Oh My. My name is Jeff Bertoft, and I'm an HTML5 evangelist here at Microsoft, and I work inside of the Windows Evangelism Group. So basically, I get to work with developers like yourselves who focus on HTML5 web applications and also Windows 8 HTML5 applications. So it's great to be here with you today, and we're going to talk a lot about inputs. And one of the real differentiators between Windows 8 and a lot of the other platforms is the variety of inputs that we support for users to use and developers to get behind. So this is the agenda of the topics we're going to cover today. First, we're going to look at the built-in benefits that come with Windows 8 applications, some of the free stuff out of the box, gestures and pointers, then input-specific interactions. Then we'll look at some non-traditional inputs, and then kind of put it all together and do a little recap. Okay, so when you start up a Windows 8 application, and you can start from one of our many templates that we have out there, you get a lot of components for free. You get things like the app bar, things like pinch and zoom, buttons, scrolling, that all are very touch-centric, that respond very well to touch. And I'm actually going to switch back and forth between my box and this computer here to kind of give you some examples of what I'm talking about. We'll look at some demos. We'll look at some code. This is the Bing Sports app, and it's a very touch-centric interface. Has things like semantic zoom that allows you to zoom in and then go to a different section of the app. Has the navigation that's built in, buttons that all respond to your touch. But there are also mouse controls for all of these same inputs. So just as we can scroll with our touch, we also have a very elegant scroll with our mouse. We have semantic zoom that allows us to zoom into the different areas and select something different. All of our navigation works with both touch and mouse, and things like stylus as well. So it also works with the stylus. So what we basically have is a very touch-centric, touch-first design that also has a very elegant interface for keyboard, for mouse, and for stylus as well. So when you have an application, you get a lot of those things free just by using the Windows 8 components, just by using the building blocks of the Windows 8 application. A lot of your touch interaction is going to be provided for you. So a lot of those app-level controls have both the mouse support, touch support, and work with the stylus as well. So here we like to say, if you design for touch, you get mouse for free. So we really want developers to have a touch-centric approach to their applications. When you design your interfaces, when you design your applications, we want you to think about touch and think how it's going to work with the hands-on. But we also want to provide an easy interface for you to also support mouse and to support styluses as well. So that's all built in. If you design it with touch in mind, then you're going to get the mouse and the stylus for free. So I want to show you another example of a simple application that kind of encompasses that. Now, I mentioned I'm a HTML5 guy. And I'm going to try to spread the love a little bit and not only show the examples in HTML5, but try to get some XAML and C# in there for you guys as well. But the important thing to remember is that the principles that we have for designing is the same whether you're using HTML or whether you're using XAML. Now, this is an app that I pulled from the IE test drive page. It was a web app. I threw it inside of a Windows 8 app. Upgraded the logos a little bit here. And it's basically a very touch-centric app. You can see I move my finger around the screen. All the little logos chase it around. It supports single touch, supports multi-touch, have different modes for it. If any of you happen to have a 2-year-old in your life, whether it be a child or a niece, nephew, neighbor, this guarantees hours of entertainment. Throw something like this in front of them and it'll keep them going. So it's very touch-centric design, but without making any changes to the way I developed this application, it also supports a mouse. So I have a single input version with a mouse and a stylus as well. So if I take a stylus to the screen, it also supports that. So let me do a little poll, and maybe it can wake you up a little bit. So how many people in the room here would consider themselves a JavaScript HTML developer? Okay. How about XAML? All right. C++? Anything? Objective-Cs or anything like that? It's like one guy in the back. I'd sit in the back too. So when we develop applications, and I know this is especially true for web applications, we look, in the past, we've always looked at touch as being an upgrade to click. So we do a feature detection on your device when you hit a website, and we say, okay, do you support a touch screen? And if you do support a touch screen, we attach listeners for touch instead of attaching listeners for click. So I would venture to say that no matter what language we come from, we've all been used to developing either for a touch screen or developing for a mouse and keyboard. So now we have a new paradigm where we need an application that can serve both inputs and serve them at the same time. The old way of testing to see whether we support touch and then attaching touch instead of click isn't going to work with Windows 8. And I see a lot of you with the Surfaces in your hands, so I know that you understand what I mean at this point. You've probably all had an opportunity to work on your Surface, and you might open an application and start with the application with a touch screen, and then fold the keyboard out and interact with it with a mouse and your keyboard as well. Well, if we make that decision for our user up front, whether we're going to support touch or click, we can't do that. So we definitely needed a new paradigm. And that's what we're going to talk about here a little bit. We'll look at pointers and gestures. And how it's going to bring in a new paradigm for us as developers. Now first, this little app that I just showed you here has a single listener attached to it. It's basically a MS Pointer Move listener that tracks my finger as it goes around the screen and forms some physics around it with all of those little logos. So I didn't have to attach multiple listeners. I didn't have to have events for the finger and then events for the mouse and events for the stylus. I wrote one event and it worked across all those platforms. Or excuse me, across all those inputs. With XAML, we have the same thing. Could attach a pointer move and fire a method that handles the physics following just that single pointer point. If I have multiple fingers touching the screen, then it fires that function multiple times. So gestures and pointers. First of all, let's look at gestures. So a gesture is an event that is delivered to you as a developer to interpret the intention of the user. So let me explain that a little bit. Instead of saying, I'm going to touch the screen, move my finger and lift it off the screen, instead of feeding that information to you, we feed you the fact that there's been a gesture move. Instead of giving you information that the mouse has clicked on the screen and then unclicked, we tell you that there's been a tap. So we interpret what the user is actually doing and pass that down as data to you. If any of you have ever had to try to write your own gesture interpreter where you're trying to figure out, okay, the user touched the screen and they actually meant to swipe, where the user touched the screen and they actually meant to rotate. That's a lot of code, especially if you want to accurately interpret what the user's doing. So what we've done in Windows 8 is we've kind of encapsulated that code and we've brought it up to this gesture level so that we can feed down to the developers that, hey, this is a gesture. Let your code respond to this gesture instead of having to try to figure out from the raw data what the users are doing. So in HTML5, we have an MS gesture hold and MS gesture tap. We have manipulation gestures, which is gesture change, gesture end start, and an inertia start. And they kind of follow the same pattern as our traditional web events. So if you've used a click or a mouse up or a mouse move, the event object looks pretty much the same, except we add some additional data in there. So it's actually quite easy for web developers or people who have developed in HTML5 and JavaScript to be able to kind of convert their code from mouse-based to being gesture-based. On the XAML side, we have tap, double tap, right tap, and holding. And we also have the manipulation gesture events where you can pull all of that same data from the manipulation event as well. So whether you're using HTML or you're using XAML, the same information is available for you. Okay, so this is the Windows 8 touch language. And you've probably seen this slide a number of times. When we developed Windows 8, we wanted to try to come up with a unified interface for users to be able to quickly learn how to interact with applications. So the Windows 8 touch language is a set of gestures that developers can use to handle certain functionality that users are already going to be accustomed to. So as I mentioned, I'm a dad. I actually have 3 kids. And being a dev dad, they're actually test subjects, 3 test subjects. And I love to throw different devices in front of them and see what happens. I love to see what they do when they get something new and which devices and which applications are easy for them to learn and which ones are more difficult. And, you know, by doing this very scientific study in my home with a 5-year-old, you're able to start to see why it's so important that we have consistency in our language. Well, if the patterns from one application to another are the same, and Windows 8 has chosen some very simple patterns that once users learn these few different gestures, they can basically navigate through any application. And as long as the different applications all use this same language, it's going to be a very coherent experience and easy for users to catch on to. If we all developed our own gestures and you draw an 8 on the screen to go back to the start menu or something crazy like that, it's actually going to be quite difficult for your users to not only learn how to navigate through your app, but it would make it harder for them to navigate through the whole ecosystem if every app treated gestures differently. So we really wanted to make sure that the data that we provide from gestures helps you to be able to utilize these different gestures in the touch language for your application. So you'll have things like press and hold, tap, pinch and zoom, swipe from the edge. Those are all information that you can easily pick up from the gestures. You don't have to dig into the input data too deeply to figure out that this gesture by the user should result in this action. So we have made a few changes to our gesture model since some of our earlier releases of Windows 8. So I wanted to make sure that I pointed that out. We do now support multiple concurrent gestures, so you can have more than one gesture on the screen at once. So a great example is if you have a UI with different sound channels where you have sliders going up on the screen. Each of those sliders can have their own gesture attached to it. So you can have a different gesture that reacts for each of the sliders and control them independently. You have explicit control over what elements are targeted by a gesture. So you tie a gesture directly to a target. And that target can then have listeners attached to it to report that specific gesture. The events return transformation data in a form that's easily consumable. So if you're taking a transform data and turning it into something like a CSS transform, you can actually directly translate that data now instead of having to do a bunch of really hard math to translate our manipulation into the CSS one. So we try to make it a little easier. Now, there are going to be times when the gestures don't provide all of the details that you need about what's going on in your application. So we also have pointers. Pointers provide a unified way to get your mouse and touch and stylus data. There's a number of pointer events: pointer pressed, pointer release, move, exited, entered, and canceled. That's what they are in XAML. And every touch point on the screen has its own event object. So if I have 3 different touch points on the screen, whereas they might be interpreted as one gesture, they're each going to be interpreted as separate pointers. And I'll show you a little example in a minute. You can definitely use gestures and pointers together. It's not one or the other. So in HTML5, we have an MS pointer down, MS pointer move, MS pointer up, over, out, cancel, and hover. And these are designed to kind of follow more of our traditional JavaScript events that we have from the DOM. So it's very easy actually to take your current mouse events, your mouse down, mouse move, mouse up, and translate them to pointer down, pointer move, pointer up, and not have to change any of your code. All the same data is provided through the pointer. We just provide some additional data within the pointer. So if we had 3 different touch points on the screen, we would then have 3 different objects that would be produced, 3 different event objects. So if you have a listener firing a method and you touch the screen 3 times, that method would be fired 3 times. So it makes it very easy to handle a single input like a mouse or multiple inputs like touch, supporting multiple fingers. I'm also very pleased to inform you that Microsoft has submitted this to the W3C for standardization as a pointers standard, so that when we write our applications, we can use pointers and support them in any browser. So we're really looking forward to that and seeing how the other browser makers adopt them. But it is a really natural upgrade from a traditional click event. And like we kind of mentioned at the beginning, when you have an application that is testing for touch or click, we run into a real problem with a device like Windows 8 that supports both. So pointers is definitely a solution to that, and Microsoft has submitted that as a W3C spec so that we can share that love a little bit. So as I mentioned, for HTML5 and JavaScript, it's a familiar upgrade from a click event model. For XAML, it's a touch, mouse, or pen on the screen is converted to the equivalent Windows runtime pointer. Okay, do a little demo to kind of illustrate the difference between a pointer and a gesture. So I basically have a blank canvas here on my page, and when I touch the screen, I'm going to be painting on that. The first thing you notice is it actually is measuring details more ingrained than what you would get from a traditional click object, because it's actually passing in the width and the height of the touch area as well. So notice if I have one finger on the screen, I get a single line, 2 fingers, I get 2 lines, and provide some additional data there. It also works with the mouse. So when I drag my mouse on the screen, I don't have a width and height value of my mouse, but it will also draw the same, and then with the stylus as well. So again, you can kind of see here, I developed this application with touch in mind, but it just works with the mouse and just works with the stylus. You also get a value of pressure whenever you use a stylus as well. So provide some additional detail. Now when I switch over to a gesture, when I put 2 fingers on the screen, you'll actually see one gesture reported. So whether I have a 2-finger swipe or 2 fingers rotating or a single finger, I'm only reporting one gesture. Now if I switch back to the pointer and have 2 fingers on the screen, I'll get 2 separate events. With the gesture, they're just one event. And you can kind of see there on the far right side of the screen, I also have additional information that's being reported about those events that makes it really easy to interpret what the user is doing. I put in things like velocity, rotation, and expansion of the fingers. And one of the great things is that we're not picky about how many fingers are on the screen. It's not 2 fingers does this, 3 fingers does that, 4 does something completely different. It's a gesture. So if I swipe with 1 finger, if I swipe with 2 fingers, I'm getting that same gesture for it. If I rotate with 2 fingers, if I rotate with 3 fingers, same difference. And as you can see, I can even use my mouse. And with the pointers, I could use my mouse and my finger at the same time. So between gestures and pointers, you have a vast amount of information available to you for developing your applications. I want to show you a little bit of the code behind that. So as I mentioned, this is a JavaScript application that's put inside of a Windows 8 app. So for the pointers, the first thing I'm doing is I'm attaching an event listener to the screen. So the MS pointer move, I actually have 2 canvases, which is why I have 2 separate add event listeners here. But I'm attaching an MS pointer move right here to the screen, which calls a method called paint. And paint's down here, and all I'm doing is doing a rectangle fill on my canvas and then reporting out the metrics from it below. But you can see one listener attached to the page responds to multiple inputs. So I'm very accustomed with a mouse to adding a click listener, a single listener on an event. So I can add that same single listener. I can support a single finger, or I can support multiple touch points. For a gesture, the first thing I'm doing is setting a new gesture object, and then I set the target of that. Remember how we talked about having multiple gestures on the same page and being able to specify a target? So I'm setting the target to be my canvas element. I want to get down the page a little bit. I actually take that same target, add an event listener to it, with each of the different gestures. Now this is a little bit different. Whenever I had a pointer, I attached a single listener, and it reported back for multiple touch points. It's kind of the opposite here. I'm adding a listener for every gesture. So in this way, you don't get a gesture object and then have to filter out the gesture that you're looking for. If you have an item that you're looking for a tap gesture on, you don't have to filter out the different gesture objects. You can just add a listener for a MS gesture tap, and you'll only get that gesture fed to that canvas. So and likewise, I add these listeners to the canvas, and go up to the same method and paint on the screen the information I get back from the gesture and report some of that information onto the left side of the screen. So a very simple application, but a good illustration of the difference between gestures and pointers. One of the things I want to point out is, you can kind of see here, when I call that paint method, I'm filtering out my pointer information. In the case for this application, I'm just filtering that out and telling it to ignore the pointer information. But you can actually utilize the pointer information that you get from that same target as well. So you can use pointers and gestures together, and the feedback from the pointers fire one method, the feedback from the gestures fire another. A lot of flexibility. So there's going to be times when you want your application to behave differently depending on the input type. So it is very nice and very handy to be able to develop your application for touch and then get the behavior for mouse and for stylus for free. But at some points, your application needs to behave in a different way when you're using a mouse. The simple fact of having multiple touch points when you're using a touch screen, you only have a single touch point when you're using a mouse. And you may have some users who don't have a touch screen, so it would be their only option. So inside of your pointer objects, there's actually a pointer type attribute that you can utilize to determine what type of input is being used by the user. So in this case here, I have a function where I'm determining that the pointer type is pen. So inside of the object, I have two different values here. I have the pointer type, and then I have the event pointer type pen. When those two are equal, I know that it's a pen that's touching the screen, and I can do something completely different for that pen. You can do the same thing for a mouse. You can do the same thing for touch or any other future pointer types that might be developed. So same thing in XAML. Again, you have an event.pointer device type, and when that's equal to your input pointer device type, then you know that you're using a pen, and same thing, you can filter out the pen-specific functionality for that. So there are going to be some interactions that are going to behave differently when you're using a mouse than when you're touching the screen. And some great examples are some of the CSS values that we've put into Windows 8. I have two examples up here. The first one is a zoom. So when I'm on a mouse device and using my keyboard and mouse, I have anticipation that I'd be able to zoom in on this page and see the content. But when I'm using a touch device, I have the anticipation that I'll be able to zoom onto the screen and zoom into certain areas of the page. So we actually have an attribute that allows you to, while the user is using touch, to be able to specify an area that's zoomed in on. Let me lower this a little bit. So here I have a picture of Mount St. Helens from one of my recent family trips. And I have the zoom area set to this. So when I'm using the touch interface, I have one behavior. When I'm using the mouse interface, I have a different behavior. So another one is the CSS snap intervals. So I have here a few different examples of some scrolling. When I'm using a mouse, I have a pretty definitive control over a scroll. So I'm actually just using a traditional overflow scroll here. I have, again, some pictures from my family trips. There's the little kiddos. Aren't they cute? And when I scroll through, the scroll bar lets me decide where I want to start and end. When I'm using a touch device, I don't have the same definition and control. So we've added a feature called snap. Down on the bottom here, this CSS carousel has a snap position in it. So when I'm using my mouse, I have free control over how quickly I scroll through that. When I'm using touch, it actually snaps to a particular interval. And in this case, I have it snapping to every 405 pixels. That's 400 pixels for the image and 5 pixels for the gutter. So as I scroll through here, you can see it tracks along with my finger, allows me to scroll. I can go forward, I can go back. This is something that we've tried to do in JavaScript as well to kind of make it easier for you to utilize touch on this type of overflow scenario. But what we have with this JavaScript, this is actually jQuery with a carousel plugin. You can see it's actually waiting till after the event happens to trigger the action. So instead of being able to track with my finger and scroll as my finger scrolls through, kind of has a reduced functionality there that only moves after the event happens. And for the mouse, it's actually a click event. So as you can see, we have different interactions that are provided out of the box. And these are actually very simple code samples here. For the CSS, I'm adding one attribute or two attributes for the overflow snap. I first have the scroll snap type and then the scroll snap points, the interval, which I mentioned was the 405 pixels. And for the zoom content, I'm setting an MS content zooming set to zoom on that particular area, and then it knows which part of the page can zoom in. So it only took a few lines of code to get that set up, but it provides a different experience for the mouse user as it does for the touch user. Now, there's going to be times when the built-in components don't meet your needs, and then you can move down to gestures and really interpret what the user is trying to do. There's going to be times when gestures doesn't provide you enough information, so you need to move to the pointers and really get more exact information about what's happening on the screen. And there are going to be times when those interfaces aren't enough to derive the information that you need. So there, we do expose the interaction APIs for you as well. So we have Windows UI Core, Windows UI Input, Windows Device Input. If you have a game or something that has very specific needs and you just kind of need a dump of the information that's being provided, whether it be the pure input on the screen or information about the mouse and additional buttons, or the stylus, whether the barrel button is being pressed or the eraser or something like that, we do provide that to the developers as well. So that data is there. So going beyond the traditional inputs, a lot of the applications that we have today do support your primary inputs very well, your touch, your mouse, and your keyboard. But we also have generally a lot of other devices or sensors that we can derive information from as well. So we have accelerometer, camera, microphone, GPS, light sensor, and the Xbox controller, which we'll demo here in a minute. But you're going to have a lot of different inputs that you can collect about what's information that's inside the device or information from devices that are plugged into your computer that you can use as an input. So for a little bit of a code example, it's quite easy to get a hold of the information from something like the accelerometer. We have the Windows Device Sensors accelerometer class where you can pull the information that's being reported from the accelerometer. Here I'm reading the accelerometer X, Y, and Z and reporting it into a div on the page. We have accelerometer, camera capture UI, media capture. There's quite a few of them between Windows devices and Windows Media for you to get a hold of. But there's also ways to dig into the code a little bit and provide some fun inputs to differentiate your app from other ones. So most of you probably saw the demo that Googs did on Tuesday morning with the Agent P game, where he was playing the game and he then pulled out the Xbox controller and plugged it in and started playing with that. So for those of you who missed it, so this is the new Agent P game that hit the market this week. It is a lot of fun, and it's going over really well. I've heard a lot of great things about it. So in this game, I'm Agent P, and I'm running through this world. And this is a really great example of supporting multiple inputs. First of all, when I have a touch screen, I have touch screen controls on there. And some users may only have a touch screen. This might be their primary way to play the game. It also works with keyboard. So not all users will have touch screen. So keyboard controls allow me to play the game just as well. A little platypus here. For a little bit more of a lean back fun, I'm going to take the Xbox controller and plug it into the side. And then I can control that same game with the controller. Now, one of the real important things to me is that I didn't have to restart this game to get the controller to work, or I didn't have to restart the game to switch from touch inputs to keyboard inputs. I was able to just kind of seamlessly switch between them depending on what was most comfortable for me or most exciting for me at the moment. I could probably do that all day if it didn't stop. But it gives a really flexible input model for this application. I'm going to pull up just a sample of kind of the input code that we had there. So what we have, and you can kind of see over here on my solutions panel, I have two components in this application. I have my base JavaScript component, and then I also have a C++ component. So one of the great things about building applications in JavaScript and HTML, and XAML as well, is that you can actually bring in these C++ components, or a XAML app can bring in a JavaScript component, or a JavaScript app can bring in a XAML component to handle functionality that might be easier to do in the other language, or might just not be possible to do in the language that you're writing it in. In this case, it's the xinput driver info that I'm looking for, and I don't have access to that from JavaScript natively. So I brought in the C++ component to collect that information from the driver and expose it into a public object. So I have my public game controller object here, and it's going to report out the different values that I'm getting from the controller. So it will tell me whether I'm hitting the X button, or tell me when I'm hitting the A button, or tell me when the D-pad is going right or left. I then move over to JavaScript, and I have a controller object, and I think I'm right above here. You can see I have a new game controller instantiated, and this ties directly into the exposed public object that I get from C++, and it has access to those the controller info. So I'm checking the state of the controller to see if it's connected. So as I loop through my game, I'm also checking to see if the controller is connected. That way, if I start out with the controller disconnected, connected in the middle, it'll still work. It'll pick that up, and then it'll start reporting the info for each of those buttons. Then I just check to see which of those buttons have changed, and I basically fire the same functions that I use for the keyboard controls. So it really did not take much code to get this additional input, but it added a lot of value to the game itself. Those are just the code samples there that we went over. Okay, so I want to show you another quick demo here that kind of puts together all of the concepts of the different inputs, marries some pointers with some gestures. Have any of you seen the website Never Mind the Bullets? It's a website that we put together a few years ago that's kind of a cowboy comic strip with a parallax effect, and it takes you through this comic strip, and then at the end it lets you develop your own comic and kind of put together the comic itself. So it kind of inspired me to put together this little demo, and I'll readily admit this is a work in progress, so don't judge me by my design skills here. But I want to take a little bit of a different shift, and one of the things that you start to realize when you have access to all these inputs is that you're not limiting your device to being a content consumption device. You really can do creation with a device when you have the flexible input model. So what I wanted to do here is I kind of wanted to build a little model that allowed you to make your own interaction. So I basically have a button here. I start and it kind of starts playing my film strip. And nothing's really happening on the screen because I haven't asked anything to happen yet. But I'm going to go ahead and touch it and rewind. And as you can see, I have some great built-in gestures. This is actually just an overflow that has the inertia at the end. So I'm going to start at the beginning again. And I'm going to hit go. And then I'm going to hold down one button and move with another finger. So you'll see I'm kind of a little jumpy here, but moving it over. Now when I rewind it, it remembers what I did while the film was playing and kind of plays it back. So here's a good use of two fingers being used on the screen at the same time, but doing two very different things. So maybe I didn't like that so much, so I wanted to just start it over again and start my screen moving. I have kind of a rough finger here. Just be moving the background a little bit. Then I'm going to rewind it. And I'm going to go into the next layer. So I have another independent layer that's going to be controlled whenever I hit that button. So there's a little bit of stuff in the air here, so I'm going to make the air float around a little bit. And again, two separate inputs. And this is definitely a touch-centric experience. It was designed to be handled by touch, designed for multi-point touch where I have two different fingers on the screen doing completely different things. I'm going to go ahead and make my cowboy now kind of march towards the saloon. And as you can see, it's actually playing the other data from the inputs before. So since I made the sky move at that frame, it's moving the sky for me. So I don't really have to think about the timing that I had from the previous interaction. It's recording and it plays for me, so I can just kind of move my cowboy along. So now I'm going to take the bird. I'm going to move my bird around the screen. Go up here and fly away as the cowboy goes off. There he is. So I can play it back and see what it is. Now, one of the things that's been bothering me this time is that the background is still kind of choppy and it's not real smooth. So what I'm going to do is I'm going to add another interaction, and I'm going to slide across the button, the background button, and that's going to put a Y lock on it so that it won't move up and down. It'll only move on the X axis. So I'm going to go ahead and do that. And now you can see my finger is moving both X and Y, but only the X value is changing. Didn't help a whole lot, I guess, but there, a little smoother. Now, the bird doesn't look very real. I'm sure we've all seen a real bird before, and that's not it. So I want the bird to kind of flap his wings a little bit and, kind of coast through the air. So I have another control down here. I just have a gesture here that's just measuring the manipulation. And as I move it, it's going to move my bird back and forth and kind of let him coast through the air a little bit. Okay, so now I play through it. And you can see the feedback from each of those inputs are playing together. There's my bird kind of waving through the air. Cowboy going into the saloon. So I was able to use multiple inputs, kind of create my own little scenario here. Now, I had mentioned that I had created this for touch specifically. I mean, it's definitely a touch-centric interface. But one of the things that I realized is that as I went through this, I actually get a lot of the mouse interaction for free without doing any additional coding. So here I'm just scrolling my mouse wheel through, and as I go through, it changes the position, allows me to start in a different place on the in our timeline. And then I thought about the controls on the side. Well, I needed multiple fingers for these controls, so I had to come up with some kind of specific interaction for the mouse. If I want to be able to do this with a mouse, I've got to have something where I can tell that it's a mouse and then do a little bit of a different functionality with it. So what I did is I have a type check for the mouse, and if it's a mouse that's being used when I hit this button, instead of having to hold the button down, it just locks the button on until I stop it or hit the button again. That way I have the mouse free to do some other interactions here. So I'm going to go ahead and start, and then I'm going to hit my cowboy, and now I'm going to move my cowboy. And you can see with the mouse I can do a lot smoother of a move. So now I'm able to, with just some small changes, support not just touch, not just multi-touch, but also mouse as well. And it actually works quite well with the stylus. In this case, I'm going to use my hands and the stylus at the same time. So I'm going to rewind it to the beginning. I'm going to go ahead and hit go, and then I'm going to get my cowboy. And now I use my stylus, and I actually have a pretty smooth start for that. Cowboy into the saloon. And now you guys know I wasn't happy with the background, so I'm going to actually go back, hit that again, and then use my mouse to move the background, or excuse me, my stylus to move the background. Nice smooth input. So there we go. So I have this content creation scenario here where that was developed specifically for touch, but with a couple small changes. It's able to support mouse and keyboard and a stylus as well. So this consumes both pointers and gestures. It's just kind of a conglomeration of all of them. The only thing I didn't get in was the Xbox controller, but maybe in a future one. And if you really start to think about it, there's so many different scenarios I could add to that. I could easily use an accelerometer on the bird, right? And measure the values, the XY values from the accelerometer to kind of decide how smooth the bird moved and things like that. So there's a lot of details from the inputs that I can collect to really make this, your applications flexible and stand out from the rest. Okay, it's a little bit of a recap. So we said at the beginning, design for touch and get mouse for free. It's probably more accurate to say we code for pointers and gestures, and we get touch and default mouse and pen behaviors for free. So pointers and gestures are there for you as developers to get easy access to data that already has some intent built into it. So with gestures, you can clearly see what it was that a user was trying to do on the screen. With the pointers, you get the information about different touch points that are on the screen as well. So use gesture events whenever you want easy access to the Windows 8 touch language. We spend a lot of time on the touch language there. It really is important that we utilize that whenever we can. We want our apps to be creative. We want them to be differentiated from the other apps in the market. And that's really where you can reach out to some of the non-traditional inputs and things like that to make differentiators. But whenever possible, use those gestures. Follow the Windows 8 touch language. And when you do use some of the non-traditional inputs, make sure that your device has a fallback for that as well. You don't want to assume that your user is going to have an accelerometer and then write your app for that and realize that you're not supporting a large majority of your users. Remember that some interactions do require different functionality depending on the interaction type. So it's not always, although you do get your pointers for mouse for free whenever you do design for touch, multi-touch doesn't always translate perfectly into a mouse event. So like we saw with the, never mind the bullets there, sometimes you have to make some changes to cater to the specific input type. We really try to make it easy for you to support all of these flexible input models. We have our main inputs, the stylus, touchscreen, and mouse. And we also have a great way for you to support all of these devices that are out there already in users' hands. So a lot of users have Xbox controls. They have a mouse that they might connect to their Surface. You know, they have a lot of these inputs, and utilize those and support those when you can. So I'm looking forward to seeing some of the great flexible inputs, well-supported input applications that hit the market soon. So here's some resources for you for developed design, some samples, and where our videos will be posted after this event. So we have a few minutes. If there's any questions, we have a couple microphones open in the center here. All right. Well then, thank you for your time. I'll be up here for a few minutes if there are any additional questions. Have a great day.